Pause the video now, guys, and try this question. Can you get 7 out of 7? So 7 marks on a A-level maths, pure maths exam style question involving parametrics. Okay, so pause the video, try this question, and then press play when you're ready, okay, to check your answer. Question number published here. A curve has parametric equations x equals log t plus 1, y equals t squared minus 5, where t is greater than minus 1. Part A, find the point where the curve crosses the coordinate axes. Okay, one way to do it, okay, is to rearrange this equation to and then sub it into here to get it in the form y equals f of x. Okay, which I'm going to do actually here, but in the live I did it in a different way. Okay, so I'm going to rearrange this. So I'm going to take e's of both sides. So I'm going to have e to the x, guys, equals t plus 1. I'm now going to subtract 1 on both sides to balance each side respectively. Therefore, t is equal to e to the x minus 1. I'm going to substitute it into y equals t squared minus 5. Okay, obviously not forgetting to square this whole bracket. So we're going to have y equals e to the x, okay, minus 1 all squared minus 5. Okay, I'm now going to expand this bracket. So I'm going to have, okay, it's going to be a double bracket. I'm going to have e to the 2x or e to the x all squared. Okay, subtract e to the x, subtract e to the x. So I'm going to have minus 2e to the x plus 1 minus 5. So that'll be minus 4. Okay, so this is going to be my equation for y equals f of x. All I now do is just set x equal to 0, y equal to 0, and then obviously find my point of intersection. So when x is 0, okay, I'm going to have e to the power of 0. So that'll be 1 minus 2 minus 4. So when x equals 0, okay, for my Cartesian equation, okay, y is equal to minus 5. Okay, so that'll be one of my coordinates. Yes, it'll be 0 minus 5. Okay, on the y-axis. What about the x-intercepts? Well, again, that'll be a bit more trickier. Okay, essentially, I'm going to have like a hidden quadratic. Okay, essentially, I'm going to be solving. Okay, if I let u equal e to the x, okay, and I'm going to have a quadratic here. So I'll set y equals 0. I'm going to have u squared minus 2u minus 4. Okay, so if I solve this, I'm going to obviously complete the square. So I'm going to have u minus 1 all squared minus 1 minus 4, so that'd be minus 5 equals 0. If I rearrange this to make u the subject, I'm going to have u is equal to 1 plus or minus root 5. But remember, that's what u is equal to. Therefore, to get x, it will be log of this. So x will equal to log of 1 plus or minus root 5. Now we can see that one of our roots will not match because I cannot have a logarithm of a negative number. So I'm going to disregard the negative signage. So it crosses the x-axis at x equals 1 plus x equals natural log 1 plus root 5 when y is equal to 0. And that, guys, is going to be my point of intersection. Okay, with that, I know that was actually pretty long here for like a 2 marker. Okay, but that's my way of obviously doing it. Okay, the reason I say that is because part B would involve differentiation, and I thought, well, rather than do differentiation obviously twice, I can differentiate and obviously work out the value of x and y. Okay, so that's my answer for part A. It was obviously pretty long-winded. Okay, but this is probably my preferred way of doing it, because when it's in Cartesian, then you can integrate or differentiate, okay, as you would normally. okay, without having to faff around with like the parameters. Okay, what can I do now? Well, part B says find the equation of the tangent to the curve when t is 3. I'm going to put in t is 3 into here, and then I'm going to differentiate this, and obviously sub in the x-coordinate for for t, and then that will give me the gradient here, and then I'll do y minus y1 equals x minus x1. So when t is 3, y equals 3 squared minus 5. 3 squared is 9. Okay, 9 minus 5 is going to be 4. So our y coordinate is 4 when t is 3. What about our x coordinate? Well, x is, I'm going to plug it in. I'm going to have t plus 3, so I'm going to have x equals log of 4. Okay, I'll leave it in this form here because I wanted to do it with that exact form. Okay, I'm now going to differentiate my Cartesian equation, so y equals f of x. Okay, so dy by dx. Okay, differentiating e to the 2x. Okay, I'm going to have 2e to the 2x. And then differentiating minus 2e to the x goes to minus 2e to the x. Okay, remember that e to the x differentiates to e to the x. If it's e to the power of ax, then the power comes down as a multiplier. So yeah, if it's e to the ax, then it becomes ae to the ax. Plug this into here now. We're going to have 2 lots of e to the power of 2 times log 4. Okay, I'll write it as log 4 squared, just so yeah, it's a bit more visible to see. Okay, now what's going to happen here? Well, the logs the e's and the logs will just cancel each other out. 4 squared is going to be 16, so 2 times 16 is going to be 32. Okay, and then minus 2e to the log 4. Again, minus 2e to the log 4. The e's and logs just obviously cancel each other out because they're inverse functions. Give me just 4. We've got minus 2 times 4 will be minus 8. We've got 32 minus 8, which is going to be 24. So the gradient is going to be 24 for x equals log 4. And then all I now do is do y minus y1 equals x minus x1. And therefore, guys, that will give me the equation of the tangent, okay, to the curve. So y minus 4 equals m brackets x minus x1. Remember, log 4 is just a number. Okay, I'm leaving it as log 4. You leave it in that exact form. Expand the bracket and then simplify. We're going to have y is equal to 24x. Okay, be obviously careful here, so be very careful here. Minus 24 log 4. And then plus that 4. Okay, and that's my answer in exact form. Obviously, if you want to simplify it, just obviously bring that into your Casio. Okay, and then obviously round that to 1, 2, or 3 dp. Okay, but me personally, I like to obviously leave things here in like exact form, so we can't like make room for error. Okay, but that, guys, is my answer to part B. Okay, and that's how we find the equation of a tangent for a parametric equation. Again, quite long-winded. Okay, but this is one way of doing it. Okay, another way, of course, is obviously differentiate these obviously like implicitly. So work out dx by dt, dy by dt, and then use the chain rule. Dy by dx is dy by dt times dt by dx. The dt's cancel, you mean dy by dx. Okay, and then using the formula y minus y1 is equal to m brackets x minus x1. Okay, so once you have your gradient and then a pair of coordinates, then all you just bang it into this formula, rearrange it so it's in the form y equals mx plus c, or rearrange it in the form that your exam board want you, whether it's y equals mx plus c, or ax plus by equals c, or ax plus by plus c equals 0. Okay, either option. Okay, well, that's my answer Question number 5. Let me know in the comments, did he get 7 out of 7 or did he get partial marks? Hey, thanks for watching. Take care. All the best.